Uh-oh, a new update's available. No, I don't want to go there. Phew. Dodged a bullet there. So today, what is today? The 10th. Today's 10-10, 10-10-22. And we are going to learn powers of I. That's honestly just our entire objective for the day. That's it. One thing. And it takes a little bit of time. When all is said and done, don't worry, we'll clean this up into a nice little package that you remember that box that you made in your notes that had if it's greater than a positive, you do a splitter, and it's nice to have a resource like that, kind of that one-stop shopping. So we'll make one of those for you here, but to kind of clean and wrap all this up in 10, 15 minutes or whatever, but it'll be a little bit weird at first. So you really want to focus today, right? And laser-like focus. So we're going to start by doing the non-negative powers of I. We're going to save I to the negative powers until the second half. So to begin, we're going to talk about I to the power of 0. I guess maybe I would be remiss for not having said this, but it's not like we don't know who he is. Are we all clear on who I is? What is I? It's not -1. It's the square root of -1. It's a massively important distinction. That's what makes him the imaginary unit, is he's the fundamental building block of all things imaginary. He says, as long as I exist, the square root of -1, then all square roots of negative numbers can be considered, evaluated, simplified, whatever. So anyways, with that said, that I is the square root of -1. What is I to the power of 0? I'll assume you know some basic rules of exponents. What's anything to the power of 0? No. It's 1. Did you know that? Did you know that anything with a power of 0 will always equal 1? Dugan, quick, what's 10 to the 0? Nice. Hey, Josie, what's -9 to the 0? What'd she say? 1. Good. I thought you said 10. I was like, what just happened? Yeah, good. So anything to the power of 0 is 1. Let's get that there. We'll move on. That's easy. So now let's talk about I to the power of 1. Don't worry, this will get a little bit less dumb. What's I to the 1? It's I. What's anything to the power of 1? Itself. It doesn't change. 2 to the 1 is 2. -10 to the 1 is -10. Like, it doesn't matter, right? Don't worry, we're going somewhere. And this is where it starts to get mathy. So here we go. What's I squared? Notice I'm just working my exponents up, right? I figure you saw that I'm going from 0 to 1 to 2, and we'll keep on going up. What's I squared? Which is what? Let's head over here and take a look at the square root of -1, because after all, that's what I is, right? I is the square root of -1. So if I take the square root of -1, because that's what I is, and I square it, what happens when you square a square root? It disappears. And by it, the pronoun it, we're referring to the radical, the square root sign. So the I squared, being the square root of -1 squared, comes out to equal exactly -1. That really is at the heart of what imaginary numbers are all about. I mean, for the first time in our existence, we just squared something and got a negative answer. I squared is -1. I don't really want to move on until we're okay there. Okay. Next in line is, of course, I to the 3rd. And honestly, the best way, I've always thought, like, as a student trying to learn this is what would make sense to me. And I think that's a lot of time what teachers do, is we selfishly explain things in ways that we think would make sense to us. So this is what would make sense to me. I would take I to the 3rd to make this make sense, and I would break it up into a couple of different things that I've already previously figured out. And they are I to the 2nd and I to the 1st. So, basic rules of exponents, that if you were to take your powers of I, you take 2 plus 1, what do you get? 3. I never mean to be rude when I ask you those types of questions, but that's the idea, is I'm taking I to the 3rd and divvying it up, if you will, into I over here, and I over here. I'm just choosing to do it that way because I already know the answers to these two things. For the first I squared, right here, what did we already figure out that I squared is? Yeah, we just learned that one. I squared is -1. And what do we know I to the first is? I. And what's -1 times I? It's just -I. Very good. Basically, as unexciting as this is, and you might find this hard to believe, you might find it frustrating, you might find it, choose some other odd word. Literally every answer on today's notes and in today's assignment is either going to be 1, -1, I, or -I, because they're all powers of I. There's nothing else that's going to happen. Now, what's going to happen here is I think I always enjoyed kind of the process of learning this. I thought this was neat. I want you to draw a little line underneath this in your notes because something neat's about to happen. I mean, maybe I consider it neat and you won't, but obviously after 0, 1, 2, 3, the next guy we have to talk about is I to the fourth, right? Now, if you consider I to the fourth as a breakdown, what's the most intelligent and efficient way to break down I to the fourth? I like I to the second times I to the second. And that's really attractive to me because I to the second is something that makes sense to me. I to the second is something I can hold on to. So you did have some options and you could work your way around to it, but the cleanest and best way to break up an I to the fourth is into an I squared times another I squared. And what's so lovely about this is we know who both of those guys are. What's I squared? What's the other I squared? And what's -1 times -1? Brilliant. Good. Correct. So what's going to start happening now, and we can do some more of them if you want to, but this would generally be the part of the lesson where I would stop. And what we are going to do now is see that there's a pattern. And the pattern, you've seen things that are what they call periodic, like it does something and then it repeats and it does something and then it repeats. You know what I'm talking about? Powers of I are just like that. And what the reason for it is because every time you get an I to the fourth, you can pull it out and make it 1. So it doesn't think about this next one, I to the fifth. I would take multiple answers, but the only one that I would write down on the board if I said, how should we break it, would be what? I don't want 3 and 2 because I to the third is an awkward one. Do better. How about this? What if I told you I demand that we do it this way? Why would I demand that of you? There's the really good answer to this question. We love I to the fourth. Who is I to the fourth? He's 1. And so every time I can grab a chunk of I's that equals 1, sign me up for that. That's the cleanest and best way to do this. I to the fourth is 1. And what's 1 times I to the first? I. And you see that the pattern has in fact reset. I don't have it up on the TV because I scrolled, but you can look 4 inches above in your notes and see it for yourself. I to the fifth, I'll be darned, was the same as I to the first. You want to guess what I to the sixth is going to be? It's going to match. And I can prove it to you by breaking it up. I can say, I demand that we break it as I to the 4 and I to the 2. And I love that because I'm always going to grab that chunk of 4 when I can. Because what's I to the fourth equal? 1. And what is I squared equal? And what's 1 times -1? We could do this all day. What do you think I to the seventh is going to equal? It is going to equal -I. So I to the seventh, if we break him up, is I to the fourth, you guessed it, times I to the third. What's I to the fourth? 1. And what's I to the third? -I. So if we have 1 times -I, what's 1 times -I? And then I think I'll probably stop after this. But do you know what I to the eighth is? It's 1. Say again? You break, so for I to the eighth, I hope by now, unless I've completely just mangled your brain, I hope you understand that I to the 8th is I to the 4th times I to the 4th, right? That seems like a no-brainer at this point. And what is I to the 4th times I to the 4th? Well, 1 times 1, which is 1. So Gavin asks, well, what happens if we jump to I to the 9th? We can continue to use things that we've already figured out, right? You see this, that we're pulling out, there's like a modular feeling to this. I'm pulling out as many chunks of 4 as I can. So if Gavin asked me for I to the 9th, which is a great question, by the way, then I'm going to pull out I to the 8th and leave behind I to the 1st, because I already know what's I to the 8th. You know it. We just did it. It's 1. And what's 1 times I to the 1st? And so undeniably, the cycle has reset itself. The bottom line, like I said, and I hope it makes more sense now, is that the answers today are all going to be either 1, -1, I, or negative I. There's no way around it. Which, of course, now begs a question, and that is, how do I approach? I'm going to scroll now, and I'm going to blow your mind with this one. How about I to the 6,433rd? It's okay. This would be a logical time to say something like, yeah, I don't have that much in my notes. Thank you. And I don't have the free time to get that far. So this is where this idea of this modular arithmetic comes into play. This idea of studying remainders. And you know that 6,433 would fit into the pattern somewhere. So we had 0, 1, 2, 3, reset. 4, 5, 6, 7, reset. 8, 9, 10, 11, reset. But ain't nobody got time to get all the way up to 6,433. So let's go back and study remainders. I'm going to scroll back up now. By the way, when we divide, anyone want to take a guess as to what we're going to be dividing by? 4, because there are 4 things in the pattern that repeat. So anytime you have a pattern that goes chuk, 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 repeat, chuk, 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 you count how many there are, and that division and remainder is always going to tell you where to go in when you get back. So dividing by 4 makes perfect sense here. So let's consider this. When I had 0 as my power, that's an implication that when I take 0 divided by 4, I get 0 with no remainder. So when the remainder was 0, the answer was 1. This part will lose you. Watch out. It's okay. I'll lose you and then I'll unlose you. So let's take a look at the next number in line, 1. What's 1 divided by 4? It's 0 with a remainder of 1. What's 2 divided by 4? It's 0, but yeah, I agree with you, Gavin. The remainder is definitely going to be 2. And what, lastly, is this last guy, 3 divided by 4? It's 0 with a remainder of 3. Now, let's jump ahead. Let's jump past this horizontal white line to the next. I'm going to switch to green now. What is 4 divided by 4? It's 1 with a remainder of hot dog. And so the pattern repeats. What is the next one in line 5? What's 5 divided by 4? It's 1 with a remainder of, what is 6 divided by 4? It's 1 with a remainder of 2. What is 7 divided by 4? It's 1 with a remainder of 3. And I didn't draw it, but you would see, of course, now that had I drawn it, there would be another barrier in our notes, because what's about to happen? It's going to reset. What's 8 divided by 4? With a remainder of, and so the pattern repeats. So what I'm taking from this hot dog is that if I can just divide, if I can do some 4th grade long division and divide a number by 4 and get a remainder, then I know exactly where to pop into the pattern. I don't need to go to the 6,433rd power of I. I'm going to divide it by 4. And I'm going to do some good old school 4th grade math here. If it's been a while, stick with me. And whatever the remainder is, that will tell me exactly where to go and which of the 4 answers to pick. Ready? Don't worry, we're going to tidy all this up here very, very shortly. So I had asked you for 6,433. So if it's been a while since you've done this, don't worry, you're not alone. We've all probably got some rust. Your friends in my 3rd hour class, they're super sharp on this because we've been doing algebraic long division. So we're going to take the power of I, 6433, and we're going to old school divide it by 4. And here we go. It's been a while. How many times does 4 go into 6? 1 times 4, 6 minus 4, drop the 4, 4 goes into 6, or 4 goes into 24, 6 times, 4 times 6, 24, subtract, you get 0, drop the 3. 4 goes into 3, 0 times 4 is 0, 3 minus 0 is, drop the 3, 4 goes into 33, 8 times, 4 times 8 is 32, subtract, and guess what your remainder is? Jackpot. So if the remainder is 1, that's all I need to know, because any power of I that has a remainder of 1 is going to have the same answer. And hopefully I've got you on board with that. I mean, we can go back to the very first one. The first one that had a remainder of 1, we see it right here, had an answer of I. Therefore, any other power of I, when divided by 4 that has a remainder of 1, the answer is I. So the answer to I to the power of 6,433 is I. Okay. Now let's make a nice clean table for you. So, because this is the first half of the lesson-ish, and then we're going to clean it up. The second half is monumentally more difficult at first. And if it gets out of hand and I start really making you mad, then I'll just give you the table and we'll move on. But I kind of want to show you where they come from. Good. All right, so let's clean it up. What I want in my notes is a nice, beautifully clean table. And so what I want you to put in there for this little half of your table is this is positive powers of I. This will help you a lot. In fact, this will pretty much just get you to the point where you can do the homework assignment in a very short amount of time. So here we go. If the remainder when you divide by 4 is 0. Go ahead and go back and look. I don't have it on the TV right now, but you know, when the remainder is 0, what was the answer? The answer is 1. There you go. If the remainder was 1, what was the answer? I. If the remainder is 2, what's the answer? Say it again. -1. And if the remainder is 3, the answer is -I. And you, I say this because I know you know this, but I would be remiss if I didn't say this. You know why the table ends here, right? Why would I not put remainder of 4? Yeah, it's literally impossible to divide by 4 and get a remainder of 4. That just means you don't know how to divide. So when you divide by 4, you cannot get a remainder of 4, right? That would be the same as getting a remainder of 0. Good? So the only other little addendum to this that I would say, and don't let this bother you, is you're going to see some problems that look like this. So let's say we had like I to the 14th times I to the 33rd. How would we figure this out? You don't have to figure out each one. What's the trick? You can add the exponents together. Good. So there it is right there. Boom, cat's out of the bag. So take the 2 powers of I and just add the exponents together. What's 14 plus 33? That's a 14. So the answer is I to the 47th. And now, watch how easy it is. You take 47 and you divide it by 4. How many times does 4 go into 47? You can do it that way. Let's go bigger. How many times does 4 go all the way into 47? 11 times. And what's 4 times 11? 44. 47 minus 44. That's all I needed to know. So what's the answer? Done. That's where that table is going to just bail you out again and again and again. You just need to know the remainder. That's a modular concept. You're taking chunks, reset. Take a chunk, reset. Okay. You feel good so far? Okay, so now what we have to consider are the negative powers of I. And when I was thinking about what I wanted to say to you today, I remember thinking to myself, you're not going to like these as much. But just like with this one, there's a little bit of filth in the air. And then after a few minutes, we tidy it up and make one of these beautiful little tables. And that's why this is just a one-day activity. Because once we have the tables, we just cruise right through. So for the other side of this, let's consider negative powers of I. So I say this is significantly going to be tougher just because of the things that you may or may not already know. So I think you guys know enough rules of exponents to know that when something has a negative exponent, you flip it to the bottom of a fraction. That should be fresher in the minds of you ninth graders from last year that we did some properties of exponents. And so if I have I to the power of -1, what that actually is 1 over I to the power of +1. When things have negative exponents, we reciprocate them to the bottom. So if it was like x to the -4th, we put 1 over x to the regular 4th, right? So on the bottom now, we have a little bit of a dilemma because I to the first is just I. So right now we're sitting here and the answer to this problem is not 1 over I. Got it? You're not allowed to have i's in the bottoms of your fractions because they are roots, and roots are not allowed in the bottoms of fractions. So this is the part you're going to hate. You don't yell at me. I mean, I got thick skin, I can take it, but still it might get me a little bit upset. And it's Monday, so be nice. We're going to fix the bottom by multiplying it by another I. We're going to do the same thing to the top because as you learned in like 4th grade, whatever you do to the bottom of a fraction, you have to do to the top. So having said that, you ready? What are we going to get on top? I. What are we going to get on bottom? You know this one. What's I times I? You know this. It's I squared. It's -1. And what's I divided by -1? Presto. One down, several to go. We now can add to our arsenal of awesome knowledge that I to the power of -1 equals -I. You know, Gavin, sometimes you act like a goofball, but at the end of the day, you're a pretty bright fella. Yes, what you will see is that the pattern is, quite frankly, yes, dead backwards of its positive counterpart. Nice job. Good observation, bud. So let's do I to the -2. You'll enjoy this one more. And by enjoy, I mean like maybe find it less poopy. So what is I to the -2? Well, it's 1 over I to the regular second. And we know I to the second. Who's he again? And what's 1 over -1? Jackpot. Good. Still with me? Let's do I to the -3rd. What is that? 1 over I to the +3rd. Now let's really think big brain mode here. Some of you want to just wait and see what to write down. Some of you, like Gavin, getting in ahead of the game and thinking big brain here. The bottom's terrible, but I'm a very short leap from it not being terrible. The bottom says I to the 3rd, and I don't have to make much of a modification to it to fix it. What could I multiply the bottom by to make him a good guy? That's a tough question, and I know that. How many eyes do we like? Maybe I've never asked this question before in 27 years. I've never thought to. Here it goes. What are the powers of I that we like? I don't like I to the 1 and I don't like I to the 3. What do I like? I love I squared. Why? Because just a number. What's I squared? -1. And what's I to the 4th? Regular 1. I like those. I don't like I to the 1st. I don't like I to the 3rd. But I do like I to the 4th. How many more i's does the bottom of that fraction need to be I to the 4th? I got an idea. Let's multiply the bottom by I and the top by I. Because I want the bottom to be something very particular. I say to the bottom, I really want you to be I to the 4th because I know who you are. I like you. You always want to make the bottom into 1 or -1. You got to make the bottom a non-I kind of number. So having said that, what do we get on top? What do we get on top? I. And what do we get on bottom? I to the 4th. And what is I to the 4th? And what is I over 1? Beautiful. And as Gavin quickly spotted, I think that's the quickest that literally has ever happened in my class. You do see, if you're paying attention right now, that the pattern is actually just backwards. Ready for the next one? You know it's going to be 1. I to the negative 4th. This is one that we don't even have to multiply by anything, because it's like the 2s and 4s and 6s we like, because they already kind of self-clean, if you will. So this is 1 over I to the regular 4th. And what's I to the 4th? What's 1 over 1? And the pattern again will repeat. You buy that. You should. By this point, you should. You should buy that if I did I to the negative 5th, I could just make it I to the negative 4th and another I to the negative 1. You're just always pulling out those chunks of, in this case, negative 4, leaving it to cycle again and again. So for our table, let's make a table. You ready? So these are for our notes, what we're going to call negative powers of I. And eventually you'll probably want to put these tables together into like one table. You can do that whenever. So negative powers of I. So we ready? Last time, I believe, when we made our other one, did we start with remainder of 0, right? Is that what we did? Let's be consistent with that, and I'll be consistent with my colors maybe. If the remainder is 0, what's the answer? Is that what we got?
Oh yeah, we did.
Well, okay, I'm sorry. You're right. I didn't do 0 because 0 is always going to be the same. That's my bad. I should have said that. I to the 0 is 0, or it's 1, no matter which way you're coming at it, right? So the one that we got that was a remainder of 0 was right here. Look at there. If you think of the number negative 4, right? And you divide it by 4, do we agree that there's no remainder? Okay, so when the remainder is 0, what do we get? Much better. Good. So if the remainder is 0, the answer is still 1. And that's nice because that goes for positive powers and negative powers. So there's the one thing that they have that is the same. All right, let's work our way up now. If the remainder is 1, let's go find one in the notes we just did that had a remainder of 1. I think I see it. It's right here. It's negative I. And again, if you still don't see what Gavin was talking about, it is going to be a vertical, like mirror reflection of the other table. Remember how the other table went 1, I, negative 1, negative I? This one's going to dead flip. So the first one now is negative I. What if the remainder is 2? And what if the remainder is 3? And that is it. So it works the same. It's so beautifully simple for negative powers as well. If I asked you for I to the negative 535th, it's okay. It's negative, so you know which table you're going to look at. But for the sake of long division, take out the negative and just go old school. Let's do 535 divided by 4. How many times does 4 go into 53? I'm sorry, I'm just jumping steps here. 4. Try again. Oh, okay, yeah. I mean, maybe I went too fast. I'm sorry. I should have slowed down. That was my bad. 13. So 4 goes into 53 13 times. That was my bad. What's 4 times 13? 52. So I'm going to put 52 here. 53 minus 52 is, then I'm going to drop the 5. How many times does 4 go into 15? And what's 3 times 4? And what's the remainder? So what's the answer? Done. The answer is I. Because if the remainder is 3, then I know I'm looking at that part of the table right there. Think you got it? It's a rough one. Not difficult once you get it all collected into a beautiful little place, but at first it's a little rough. So if you have any questions? Okay. Cool. There's an assignment for you. I have two things I want you to get done. I don't know. I had in my notes I wanted them both done today. We'll see how this might be negotiable. The first thing I want you to do is your Delta Math. It's assignment number 15, and it should have assigned itself like 20 minutes ago or so.